Hi students, this is Chapter 8, Lesson 7. This is the last chapter, or last lesson in the chapter, so your test is coming soon. Hopefully you've been reviewing lessons 1, 2, 3, 4, 5, and 6. This lesson is, you're going to learn how to solve one-step inequalities, and it is the 7th note page of the chapter. And today you're going to see a lot of similarities in solving one-step inequalities that you used for solving one-step equations in the last chapter. In fact, the process is almost exactly the same. All right, so let's get right to it. Solve each inequality. Solve each inequality and graph the solution on a number line. That's what we're going to be looking at our examples today and doing. Solve each inequality and graph the solution on a number line. The first example we're going to look at is x plus 3. X plus 3 is greater than or equal to 10. So I'm going to write it over here. And here's how you solve inequalities. The process looks just like what you did for solving equations. Find the variable. You undo what's happening to the variable, but you have to do the undoing operation to both sides of the inequality so that it doesn't change. So the first step is find your variable. Look at the variable side of the equation. X plus 3 is my variable side. I'm going to cover that up and just look at the variable side only. 3 is being added to x. What is the inverse of adding 3? So that is subtract 3. But I need to do that to both sides, just like we did with equations. 3 and take away 3, cancel each other out, and we're left with x is greater than or equal to 7 is what we have on that side of the inequality. So here's the solve. This is what your work should look like. Just like with equations, you're showing that you did the same thing to both sides of the equation, and here is the solution to this inequality. X has to be greater than or equal to 7. And the other thing you're doing is graphing. Graphing the solution. So because that's a 7, I'm going to put 7 in the middle. 8, 9. Here's my number line. And again, I'm going to think about what numbers can I plug into this, or instead of saying x, I'm going to say the answers. Instead of the variable, read this as the answers are greater than or equal to 7. That's greater than 7. That's greater than 7. So all of these are going to be answers. And do I want to include 7 in my answers? I do, because of that. Your answers are greater than or equal to 7, so I want to include 7. So the graph, I'm going to shade in that point because I want to include 7, and then all of these answers get highlighted. Let me make that point a little bigger. So that's what my solution looks like to graphing this. The answers are greater than or equal to 7. Including 7, and everything greater gets highlighted. So my answers just keep on going that way forever. but I do want to include 7 because of that right there. So I used a closed dot. It was not open. All right, let's look at another one. Next example, m subtract 4 is less than 12. M subtract 4 is less than 12. So I'm going to follow the same process that we did on the last inequality. Find the variable side, find the variable, look at the variable side. 4 is being subtracted. What's the inverse of subtract 4? Is add 4. But again, got to do that to both sides. Take away 4, add 4 becomes nothing, cancels each other out. I'm left with m is less than, and then on this side, if I cover up this, on that side I'm left with 12 plus 4, 16. So my answer to that inequality is m is less than 16. So on my, now I'm going to graph the solution on a number line. 16 in the middle, 17, 18, 15, 14. Now I'm going to think about, well, what numbers fit this inequality? The answers are less than 16. So 14 works, 14 and a half works, 15 works. All these answers that are less than 16 work. So I know that my answers are all going this way. The answers are less than 16. Do I want to include 16? Put 16 into this inequality. Is 16 less than 16? The answer is no. I do not want to include 16, so I want an open point. Open is not included. Closed, filled in is including. So my solution would look like this. I want an open circle at an open point at 16, and then I'm highlighting everything going this way. So there's the graph of that inequality. Again, open because I do not want to include 16. M is less than 16. The answers are less than 16 on a graph. So these are equivalent, just different ways of representing the exact same thing. Okay, before the next example, your hidden treasure vocabulary for this lesson is the word factor. F-A-C-T-O-R. Again, write that at the bottom of your note page, the word factor. Look it up. If you don't know what it is, define it, and you could give an example. So the definition of a factor and give an example of a factor. Okay, next example. 5t is less than 35. So 5t is less than 35. My process does not change. Find the variable, that's the letter. Look at the variable side. I've got 5t. That means 5 times t. That's what's going on there. T is being multiplied by 5. What's the inverse of being multiplied by 5 is divide by 5. So I'm going to show it like this. Divide by 5, but I've got to divide this side by 5 too. Remember, that line is a way of showing division. 5 over 5 turns into 1. 1t, which is t, is less than 35 divided by 5 is 7. There is my answer. The answers are less than 7. So let's graph it. Let's graph the answer set on a number line. 7 I'm going to make in the middle. 8, 9, 6, 5. Which way are my answers going on the number line? I go back to the inequality. Your answers are less than 7. So these are all my answers less than 7 going this way. And do I want to include 7? Imagine putting a 7 into this inequality. Is 7 less than 7? Answer is no. Do not include. How do I not include 7? Just like this one, I'm going to make it an open point, not filled in. And then my answers go this way. So your answers are less than 7. Your answers are less than 7 on the number line. So these answer the inequalities. Here's the inequality solved. Here is a graph of the answer of the inequality. Here is the solution to the inequality. Here is the graph. Here's the solution to that inequality. Your answers are less than 7. Your answers are less than 7. One last example, and then you get to practice. The last example looks like this. Whoops, I want blue. My examples. Got r over 4 is greater than or equal to 2. So again, the process is find the variable. That's r. That means r is being divided by 4. So I think to myself, what is the inverse of dividing by 4? The answer is multiplying by 4. So I'm going to multiply this side by 4. I'm going to show that with my parentheses right next to this. 4 over that 4 right there turns into 1. So on this side I'm left with r. 1 times r, which is just r. And then on this side, 2 times 4, which is 8. So there's my answer to the inequality. The answers are greater than or equal to 8. So again, let's graph those answers. 8 in the middle, 9, 10, 7, 6, and the answers are greater than or equal to 8. So I want to fill in all the answers that are greater than or equal to 8. Do I want to include 8? Does it work if I put 8 right here? 8 is greater than or equal to 8. Does work. So I do want to include 8 and everything greater. Your answers are greater than or equal to 8. So I do want to include 8. So I'm going to make my point and then make it closed. I'm going to fill it in. I want to include it. And then everything greater. So my answers go this direction. I put a big arrow on the end because the answers just keep going that direction forever. So there's the answer to the inequality. Your answers are r is greater than or equal to 8. R is greater than or equal to 8. Or remember, the answers are greater than or equal to 8. So all these things that are highlighted blue are the same thing, just a different way of representing it. X is greater than or equal to 7. That's the same thing. Your answers are greater than or equal to 7. Your answers are less than 16 and not including 16. Your answers are less than 16. Inequality, graph of the same thing. Your answers are less than 7. Answers are less than 7. Your answers are greater than or equal to 8, including 8 because of that, and everything greater. So the other thing I'll go back and highlight is this, that you've got to show the same thing to both sides. Divide by 5, divide by 5, multiply by 4, multiply by 4. So when you're solving your inequality, make sure you're showing what you're doing to both sides of the inequality. And when you're graphing the answers to the inequality, make sure you think about, are you including this number or are you not including that number? If it's got a line under the inequality symbol, then you are going to include it. If it does not, you are not including it. Not included open, filled in, or closed point, you are including that number. All right, that wraps it up for Lesson 7. Again, start reviewing Chapter 8 lessons. Your Chapter 8 test will be coming very soon. And the next time I see you, we will be talking about Chapter 9. All right, until then.